Our next topic is volumes. Oh. So, the volume of a prism. And there is a good visual for figuring out the volume of any prism. The formula that's given here is it says area of base times height. On your formula sheet, just seeing if I have one out here, pull one out. What's your volume formula on your formula sheet? Yeah. It has, on your formula sheet, it looks like this, but they're very nice by adding the word base in there. It's the area of base times height. Question? It started. The little red light is going. Yeah. No, that's fine. I'll put this, find a place to put this up. Okay, perfect. Thank you. Okay. Here's the visual for seeing the volume of a prism. Probably the easiest way to imagine it is using paper. Okay? When you buy a big thing of paper, it makes a prism. Right? You buy a big stack of paper, it makes a prism that way. Now, volume is measuring space inside. Would you agree when you buy that stack of paper, it is completely filled with paper, right? There's not a part of it that's like something else. There's not a hole in it that in the middle or anything like that. It's completely paper. Now, how do you count how much paper is in there? Well, you have one piece of paper at the bottom. Usually when we think of a single piece of paper, we don't think of it as having any height whatsoever. It does. There's a tiny, tiny, tiny little bit of height to it. But if you start stacking paper upon paper upon paper upon paper, all of a sudden you do get a height. And so the idea for any prism is if you figure out what the area of your one piece of paper is, and then you stack it and add that height, that fills that whole shape full of paper, and that's the volume. Volume is just the area of the base times the height. We don't have to, if you can figure out the area of the bottom, and then just multiply it by its height. The sides are for surface area, but they don't come into effect. Because if you had a saw and you cut off the corners of your paper that you bought, you would make this shape. Well, not quite, but similar. Right? I made 1, 2, 3, 4, 5, 6, 7. I made an octagon. They cut it so that it made a hexagon. But any shape, you find the bottom. What's really cool of this is you can now tell me, without looking at your formula sheet, what the volume of a cylinder is. What's the volume of a cylinder? We learned this in our notes later. I'm jumping ahead. I got excited. I'm sorry. What's the area of the bottom? What shape is on the bottom? Circle. What's the area of a circle? Pi r squared. Perfect. There's your volume of a cylinder. It's kind of neat sometimes where you learn one idea And then you now have really hundreds of formulas. You have the formula for a triangle on the bottom times the height. You have a circle on the bottom times the height, a square on the bottom times the height, rectangle on the bottom times the height. Doesn't matter what shape is on the bottom, it will get multiplied by the height. On your formula sheet, you have this one, volume, area of base times height. You have the cylinder as well. The pi r squared circle formula for area, yes, it's on your formula sheet as well. Now, what's really kind of cool is any shape that you then, if I take this shape and drew a point right in the middle and connected all of these lines, can you see that that would make a pyramid? And what's really cool is that if, no matter what shape you make a pyramid with, if you took that cone and tried to refill the prism up, it would take exactly 3 cones to fill up the original shape. And so the volume of any pyramid is just 1/3 the base, 1/3 of the prism. Maybe we'll write that. It's just 1/3 the volume of the prism. So on your formula sheet, does it have volume of pyramids? Yes. So you get this question on a quiz or a test, okay? And it says to calculate the volume of the right square pyramid. You look on your formula sheet and you see that there is this formula, and you might even want to write it down exactly as it is on your formula sheet. So you got volume of pyramid is 1/3 area base times height. And then you have to ask yourself if you have all the information for this. You want to find volume. So do we have the area of the base? No. We have to figure out the area of the base. Do we have the height? Oh. See, this is like, oh, they did that to us again, right? You look at it. Would you not be tempted in this diagram to think the height was 7? Of course. But it's not. What did they give us? They gave us the slant height. Right? Those little, right? So we need to find the area of the base. Is the area of the base easy to figure out? Yes. It's a square, so it's length times width. 2 times 2. It's going to equal 4. I can put a little check mark. I figured this out. Okay, careful. We have the slant height, not the height. This is what we want, right to the middle, H. This is what they've given us as 7. The green one they gave us is 7. We want the blue one, which is the height from the center down to the middle. We want the solid blue line. Can we make a right angled triangle with that? Yes. We can make, I can draw the blue line, the height that we want to find. We know the green line is 7. How long is the bottom part of that triangle? 1. How do you know that it's 1? It would be here. That's half of 2. And then we get to do, I hope you like a squared plus b squared equals c squared, because you get to use it all the way through grade 12. Lots. Okay, so we've got, okay, careful, because the h, will we put that on the, that's not the hypotenuse, so careful that we have 1 squared plus h squared equals 7 squared. So 1 plus h squared equals 49. Move the 1 over to the other side by subtracting 1 on both sides. And the exact value of h is the square root of 48. Square root both sides. This is the exact value. This is an approximation or a rounding. I go to my calculator. I got 6.93. Or I'll just put little squiggle brackets there because I rounded that one. Which one should I use in my formula? I should use the exact one. Right? Maybe make a little note. This is exact. This is rounded. But now I found the height. I can go back to my formula and look and go, good. I can now find my volume because I know everything to plug in. The volume is going to equal 1/3 area of the base. We figured that out to be 4. Height, we figured out to be the square root of 48. Type that into our calculator with all the exact values. And we get 9.2376. So you can check. You should be having a calculator with you as you're doing this. Whenever we do calculations, you should try to be one step ahead and have those calculations already done. I'm going to reread my question to check for rounding and units. Okay, calculate the volume. It's feet. And do you see how the question didn't ask how many units? So you can round, right? Maybe you feel like, I think 2 decimal places would be enough. I need to include my units, which were feet. And now I have feet cubed. Because volume is always cubed, and because our units in the original picture were feet, our answer is going to be in feet cubed. Do you have a visual for a foot? About how long it is? Yeah? Do you have a visual for area for feet? What a 1 foot square is? Look on the floor. North America, almost all tiles, these school ones are perfect. They're 1 foot by 1 foot. That is a 1 foot square. Okay? And if you want a visual for 1 foot cubed, question? Yeah. Take that 1 foot square, imagine a cube with those 6 of those on the side. That's how big a 1 foot square is. Okay? Now, when you're picturing how big this volume is, you're imagining 9 of these. If you bought 9 feet cubed of ice cream, just because we're thinking about ice cream all day today, that would be 9 squares. That would also be not as crazy a weekend as our first question, but still a pretty crazy weekend of ice cream. I think I better buy ice cream on the way home today. Volumes of right rectangular prisms or right rectangular pyramids. Okay. Notice that they give you length times width times height for this prism. Can you see that this is the same as this. Because what's the area of the bottom? Length times width. So notice on your formula sheet, you do not have the area equals length times width times height formula. You just have the area of the base times the height, because that's a formula that works for any shape. So it's better for us than just specific formulas. And anytime you have a pyramid, it's always 1/3. So this would be 1/3 length times width times height. Can you see that this is the same as 1/3 area of the base times the height? So again, they gave us new formulas, but these formulas are the same as the formulas that we had before. Can you draw the picture? Try drawing the picture on your own. Can you make a rectangle sort of sideways? Draw the pyramid as best as possible. This is like math artwork class. How was your drawing? So I started with the square on its side, which 3 dimensions you sort of make into, anybody know what that shape is? What shape you get if you sit on a square and bend it down a bit? Sit on a square or a rectangle? It's called a trapezoid. You knew that? Nice. Does anybody know the special trapezoid when it's a square? Starts with an RH. It's not a trapezoid. Not a rectangle. It's a rhombus. Rhombus. You don't say the H. Maybe you should. That'd be kind of fun. Rhombus. Rhombus. Okay, anyways, sorry. There we have our pyramid. We want to find the volume. According to our formula sheet, the volume of a pyramid is equal to 1/3 area of the base times the height. This time, what do we have? Do you see that we already have the height? They didn't give us the slant height. Little happy dance. This question's easier than the last question. Do we have the area of the base? Did they tell us that? No. So, first thing we need to find is the area of the base. How do we do that? It's a rectangle, area of a rectangle, length times width. So 4.7 times 3.8. Go to our calculator. 3.6. Oh, do you ever do this? Do you ever get a little bit messy in your writing? And numbers morph? Like this was supposed to be a 6, but can you see how I thought it might be an 8? Man, you got to be careful. Thank you for noticing. 3.6. Here's one I saw on a test once. The kid wrote their 3's like this. Okay? The next time, they wrote their 3 like that. The next time, they wrote their 3 like that. And then they just wrote 5s. You see how the line just slowly moved over? There's been some, there's some I wish I would have taken pictures of, like, how do you change? There was like numbers that you wouldn't think were even possible to change. Yeah, like how do you change a 7 to a 2? But they're like slowly changed it bit by bit until eventually turned into a 2. Anyways, 4.7 times 3.6. 4.7 times 3.6 is 16.92. And that's exact. So now I can find my volume. 1/3, 16.92, times by the height, which was given to us to be 6.9. Type that into my calculator. 38 decimal 916. I can use an equal sign because I have not rounded. That is exact to every single decimal place. And now would be a good time to read the question. It's in meters and round to the nearest tenth of a cubic meter. Nearest tenth would be 1 decimal place, meters cubed. I also like, when I'm doing a test, I like to circle my final answer. Yeah, yeah. All right, 2 more questions. I think we can get them done. Yeah. So, if a cylinder fits this formula because a cylinder is a special type of prism, then this one also fits that idea. Fir cone, which is super cool. How the formulas are all related to each other. All right. So here's our question. Determine the volume of a cone. When we look at our formula sheet, though, the volume of a cone, it has both. It has the area of the base one, and it has the pi r squared h1. So usually, if you have both, you would probably, volume of the cone, use the pi r squared in there with the circle in there. Do we know the height? Yes. Do we know the radius? We can find it. It's kind of like one of those mostly yes questions, right? Technically, we don't know the radius. What do we know when it's all the way across? What's that called? The diameter. So we might just take an extra bit of time to write out, yes, I know the radius. And now I know all the things on the right-hand side. This question is super easy because we can just go into our calculator, plug in the numbers. Oops, not a bracket yet. We have 1/3. We have pi. We have a bracket. The radius is 4. It's getting squared. And then we've got our height. It's 13. Did they give us the slant height? No. Thank you. They gave us the actual height. And so we go to our calculator, and we should be able to type this all in at once. Now, some of you do have a graphing calculator. If you do, check. If you do alpha y equals, you might even be able to write fractions, which is super cool. So I can even write, so I go alpha y equals, I push enter on the very first one. I can go 1, go down over here, 1/3. Then I need pi, then brackets for 4. and that's going to get squared, then brackets for 13. Push enter, and I get my answer all at once without having to do calculations along the way. If you're a scientific calculator, you should be able to type this in all at once as well. 1 divided by 3 times pi times 4 squared times 13. And we get 217.817. And it says to the nearest cubic millimeter. So I can round and include my units, circle my final answer. And our last question. A cone has a height of 8 meters and a volume of 300 meters cubed. Determine the radius of the base to the nearest meter. Sketch and label a diagram. So how do we draw a cone? We start with an oval. Make a height. What can we label on here? We know the height is 8. We know the volume. So I might write out volume equals 300 meters cubed. It says determine the radius, so I want to find r. This question's a little bit different than the ones we had before because usually we are working forward to find the volume. The questions we had before said find the volume, then you would go to your formula sheet, find the volume formula, plug things in, get an answer. This one's working backwards a little bit because they told us the volume. But we still go to our formula sheet and say, I have a formula for the volume of a cone. It's equal to 1/3 pi r squared times height. But this time, I want to find the r. So if I want to find the r, the only way that's possible is if I can put in numbers for everything else. Do I know the height? Yes, I'll put a little check mark there. Do I know pi? Yes. Do I know 1/3? Yes, those are numbers. Do I know the volume? Yes. I can put a check mark there. So what that allows me to do is rewrite the formula with numbers in for everything except for the r. Instead of the volume, I can write 300. Instead of the 1/3, I can write 1/3. I can write the 1/3, I can write the pi. I don't know r, so that stays there. But instead of the h, I can replace that with 8. And now we want to get the r by itself. So first, we're going to try to get the r squared by itself. And we could take our time with this. I have a 1/3. How would I get rid of the 1/3 on that side? I can't add or subtract because it's multiplying right here, right? But I can multiply and divide. What would get rid of a 1/3? Multiply it by 3. So if I multiply it by 3, this side will become 900, and 3 times 1/3 becomes 1. It just goes away. So I still have the pi. I still have the r squared, which I put a box around because I want to get that by itself. I still have the 8. Can you see that this is all multiplying? And I want to now introduce you to a common mistake that students make on their calculator. Can you see that I could, if I wanted to show my work, I could get rid of the 8 by dividing by 8, and I could get rid of the pi by dividing by pi. If I do that to this side, I have to do that to this side. Can you see that that would give me my r squared by itself? Okay? Type that into your calculator. I want to see how many of you make the mistake in your calculator. You ready for the challenge? It's a common mistake. It's always good to make a common mistake when you're aware of it, because then you're less likely to make it in the future. Okay, ready? Okay. Did you get 353.4? Woohoo! We're all wrong. That's wrong. Oh, man. Why is it wrong? Technically, your calculator knows order of operations, but it only did 900 divided by 8. It got an answer, and then multiplied by pi. If you want to divide by both the 8 and the pi, you would need to either put it in brackets, which, oops, most people will do, or do 900, divide by 8 first, then divide by pi second. That would, oops, also give you 35.8. Or if you have the graphing calculator and you use the fraction button, you can make no mistakes by making it look exactly like that. It works perfectly as well. So when you're dividing by more than one thing on most calculators, you're going to need to put brackets around that to tell your calculator to do it in the order you want, not order of operations, where it does one first, then the other one. So we have 35.8. That's equal, wow, there's the decimal. 35.8 is equal to r squared. How would I get r? I'd have to square root. A lot of calculators let you do square root. On my calculator, I have an answer button. So I can square root the answer. That means I haven't rounded yet. It takes all of the decimal places when it square roots it, and I get 5.984 equals r. Double check, what does it want to round to? To the nearest meter. Circle your final answer, and we are done. Okay, and there is another homework assignment for the weekend. Now,